In the previous video, we started working with objects and classes and got up to speed with that. It's now time to talk about inheritance, what that is and how that applies to objects. So to do that, the best way to get started is to go back and talk about physical objects again. Because the thing is that different kinds of objects have a certain amount in common with each other. Using an example of computers, you could say that an iMac computer, an Android Nexus 9 tablet, and a Dell PC all share the characteristics of computers, in that they've got RAM, random access memory, ROM, read-only memory, they've got the current state as to whether it's like the device is on or off, and so on. So they share common characteristics, but yet each of these devices add additional features that collectively make them different to each other. For example, an iMac runs the OS X operating system. It's got an Intel CPU. It's got a hard drive, USB ports. An Android Nexus 9 tablet, for example, runs on Android, the Android operating system, and it's got a touch screen for input. A Dell PC runs Windows. It's also got an Intel, but maybe an AMD CPU. It's got a hard drive, a mouse, and so on. So you can see that while objects can share similar characteristics, they can also be different as well. So what object-oriented programming really allows us to do is to create classes to inherit commonly used state and behavior from other classes. And one of the best ways to actually show inheritance, rather than giving you a heap of slides discussing it, is to actually immediately go into some code and actually start working through some scenarios and showing you what inheritance looks like in Java code. So what I'm going to do is I'm going to start with the analogy of an animal. So if you think of any animal, they have certain behaviors that are shared across all types of animals. For example, animals all eat. They all are able to move in some way. They've all got a body. So that's some of the basic things. But what about things like, for example, legs? Well, no, not all animals have legs, because snakes and worms are an example of an animal without legs. Eyes? Well, no, not all animals have eyes, because there's varieties of spiders, for example, that have no eyes. Do they all have a brain? Well, yes, actually they do, although it does depend on the definition of a brain. But essentially, yes, they've all got that basic mechanism. And they've also got size, and also have got a weight as well. So what we could say was we could create a very basic class that we could actually apply to each and every animal out there, and that we know that any animal would have these traits. So we're going to create a new class now and call it animal, and we're going to add some state and behavior, in other words fields and methods, to model that. So let's do that now. And I've created a new class, I've created a new project here called inheritance. So I'm going to create a new Java class, and I'm going to call it animal. And we talked about those states. So we've got brain, we've got a body, a size, and a weight. They're going to be our 4 fields that we're going to apply. So I'm going to create a private field for each of those. And we're just going to have an integer, private integer brain, private integer body, private integer size, private integer weight. And we'll also add another one, and a name, because of course every animal has got a name. So we're going to create a string for that. So we're not going to be too worried at this stage as to what the contents of these fields are. I've decided, as you can see, an integer data type for the brain, body, size, and weight, and likewise a string for the name. It doesn't really matter too much at the moment as to what type of data we're going to put in there. The main thing is what we're trying to do is just come up with characteristics, state in this case, of things that all animals have got. We're also going to create a constructor so that we can construct an animal class easily. So I'm going to just use my command to create a constructor, and I'm going to specify all 5 as parameters, like so. Then the other thing we'll do is we'll create a getter for each of those classes, for each of those fields as well, in case we need to access that later. So that's the basic definition of an animal. That would be the base class, if you will, that all our other classes that we're going to create, sort of subtypes of animals, will base themselves off. So another example of an animal is going to be a dog. So what we're going to do is create a class called dog, but we're going to inherit from this animal class. So I'm going to go and create a new class, call it dog. In Java terminology, if you want to inherit from another class, in other words, you want to be able to access in some fashion the state and behavior that's in that other class, you use the extends keyword. So we type extends and we type animal. You can see that IntelliJ has come up and given us a choice of animal. So by doing that, we're able to use the state and behavior that's been defined in the animal class in this new dog class we're creating. Now you notice straight away that I've got an error. So the error that on the screen is saying there's no default constructor available in the animal class. So what that's saying is, look, I'm trying to use the animal class, and to do that I need to be able to call the constructor for that class. That's what we need to do when we're creating a new class that extends from another one. We need to be able to call that other constructor class to initialize it. And if you recall, if we go back to the animal class, we've got a constructor there so we can initialize those 5 parameters. So what we really need to do is make sure that we've got a constructor for the dog class that calls that other class. In other words, calls the constructor for that other class. So to do that, generate, and just in case you're not sure how I'm generating that again, click on code and generate. You can see to the right, in my case on a Mac, it's Command N. You'll go to your operating system and there'll be a shortcut for your environment, for your platform. So choose that to generate. And constructor, and you can see that I just literally selected constructor and IntelliJ actually filled in the rest. So what's happened here is you can see that automatically there's those 5 parameters that actually are dealing with the animal class, name, brain, body, size, and weight, have been created as parameters to the dog class, to the dog constructor, in other words, and then this keyword super has come up. So what super means is to call the constructor that is for the class that we're extending from. So in this case, the super class, or sort of the big class that this class is extending from, using the extends keyword, or inheriting from, to be more precise. So what this allows us to do is to initialize the animal class, and if you recall, the dog is actually part of an animal class. So we've defined it as an animal class. We're saying it's based on the animal class, but what we can also do is we can add more features to this dog class, things that are unique to a dog and not just a very generic animal, if that makes sense. So that first line there, what that's done, it's initialized the basic characteristics of an animal, namely the name, the brain, the body, the size, and the weight in a constructor. But what we can also do at this point, because we're now working in the dog class, is we can assign extra state, extra fields in other words, and extra behavior, that is methods, that are unique for a dog and aren't necessarily applicable for an animal. So for example, we could create some fields, private int eyes, because remembering that not all animals have eyes, but all dogs do have eyes. Private int legs, not all animals have legs, but dogs do have legs. All dogs have legs. Private int tail, all dogs have a tail. Private int teeth, dogs have teeth. And maybe another one would be private string coat would be the type of coat, whether they've got a sort of a long silky coat or a short coat, fur, those types of things. So they are unique characteristics relating to a dog that we're adding in addition to the animal state. So you can see what we're doing here is really what we're saying is the dog has got these fields here, these characteristics, but in addition they've also got these base characteristics, but we've defined those in the base animal class because they aren't specific to a dog, and that's why we're extending from that class. So this is what Java and other object-oriented programming languages allow you to do, is to create a base class that's got the basic information to work on, and then you can extend from that class, which indeed is very powerful. Because what that also means is not only with the fields, we can also add specific methods. Like for example, going back to our animal class now, we could introduce some behaviors and we could add some methods for those. For example, all animals have to eat. So we could create a method called eat. And we won't worry about the functionality for now, but it's there anyway. Another one might be move. That's 2 methods that are unique to all animals. All animals have some mechanism, some way to move, and all animals eat in some way, shape, or form. So by doing that and making it public, if we go back to the dog class, what that means straight away is that function, that method is now available to the dog class. So the base class we've defined, we've said all animals have to eat, are able to eat. Because we've specified that method in the animal class, this method is inherited from dog automatically, and we'll be able to use it, and I'm going to show you how to do that shortly. So let's look now at this constructor, because there's two components that we need to do now if you think about it. When we're creating a dog and we're modeling a dog in computer terms, we've got those parameters that have been defined there, namely the name, whether it's got a brain, the body, the size and the weight. But we also need to initialize those other characteristics as well, namely the eyes, legs, tail, teeth and coat. So really what we'd need to do is we would need to initialize that in our constructor and not just the fields that we've defined that initialize just the animal class. Because we know in the dog class we're creating a constructor for the dog, we need to work with these extra parameters. So one of the things we can do is we can be a little bit smart with our definition here and the parameters that need to be passed. For argument's sake, we can say, we're going to say that all dogs have got brains. So instead of having to use it as a parameter, I'm going to remove that parameter there. And I'm just going to put past the number 1, which really is just our way of saying is all dogs have got a brain. Likewise for the body, we're going to do the same thing. We're not going to put it there as a parameter, because we're going to say all dogs have got a body. So you can see what I've done. I've still initialized the animal class. It's still got the 5 parameters it needs, but what we've said is we know that all dogs have got a brain and a body, so we're not going to force the programmer who's creating the dog class to have to define those. But what we will do is we will add these as extra parameters. So we'll actually add a parameter for the eyes, for the legs, for the tail, for the teeth, and for the coat. So you can see we've used some of those parameters already, and those parameters that are in the animal class have been sent on, and we've executed this constructor, and those fields have been initialized. What we now need to do is initialize the other ones. So to do that, and you've seen this before, we just do this.eyes equals eyes, this.legs equals legs, this.tail equals tail, this.teeth equals teeth, and this.coat equals coat. So effectively now we've initialized all of the fields relating to this dog. And of course some of those fields were the basic fields that were part of the animal class, and the rest were part of the dog class because they were unique characteristics related to a dog and not necessarily an animal, which may, as we've talked about before, may not have some of these features. Okay, so let's try starting some of this code now and start using some of this code, creating a new class to see how this works. So what we're going to do first is we're going to define an animal class. We're going to create an animal, a basic animal class. As you've seen us create new classes before, we're just going to create that just to confirm that it does work. So we'll be creating a new animal class. We've just got the one constructor, and you can see we need to do a name, so we'll just call it animal. Then we need a body, so we'll say that we need a brain, so we'll put 1, 1, we need a size, so we'll just say it's a default 5, weight 5. So you've seen that before. There's nothing particularly new there, but that's just a definition for a base animal. It doesn't really make a lot of sense because we want to be specific. We want to work, in this case, with a dog. So to do that, to create a dog class, we're going to type dog equals new dog. And remember, the parameters will change a little bit here. So we might call this dog a Yorkie. And we might say the size is 8. The weight might be 20, 2 eyes, 4 legs, 1 tail, 20 teeth for argument's sake, and we might say it's a long silky would be the type of coat. So that's now initializing a dog. Nothing particularly new there, you've seen that before, I'll just fix that typo. But one of the things we can do, this is where inheritance really starts making sense, is we can use some of these functions, because remember we defined these two public functions, eat and move. So what we could do, we could type dog dot, and notice the eats come up. So we're able to use the method eat, even though if we look at our dog class, you can see there's no method definition for eat. So where's the eat defined? Well, remember the eat was defined in this class, in the animal class. So this is one of the features of inheriting from another class. Because we've defined the method eat as public, we've said this method is publicly accessible. The dog class can see that, and it's extending animal. In other words, it's inheriting from the animal class, and as a result, we're able to use the eat method, even though it's not actually part of the dog class. And just to confirm that, what we'll do is we'll go to the animal class, and we'll add a system output, and we'll put animal.eat called, just so we know that where it's actually come from and which part of the code is being executed. If we run that, and you can see animal.eat called. So just by that process, even though we're accessing the dog class, it knows that the dog is a type of an animal because we've inherited from the class animal. And as a result of doing that, we're able to access the functionality that's part and parcel of the animal class, and we're able to use the eat method. But it does get better than that, because what we can also do, going back to the dog class, we can override this eat method. So what we can say is, well, like a dog eats in a particular fashion. For example, the dog chews its food. Other animals don't necessarily chew food, but the dog does chew its food. So what we might want to do here is we might want to create a private method called chew. And this is something unique to a dog. And we'll put something like dog.chew called. But then also what we can do is we can use my generate command again. And I can come over here and I can put in override methods. Now what override does, and I'm going to select that you can see straight away it's given us a list of methods, including the constructor, that are available in the animal class. So in other words, it's worked out and says, okay, I know that you're extending from the animal class. These are the methods that can be overridden. In other words, we can create a version of that same method that exists in the animal class, but make it unique for the dog class. And that's something that is inherently very powerful. And the other thing I just want to point out here is, you notice this java.lang.object. I'm going to talk about that in the next video. But what that is that every single class you create, even though it doesn't come up and show you via the use of the extends keyword, does actually get extended. You are extending this object class, which is a special class created by Java, but more on that in the next video. For now, let's override the eat method, which is part of the animal class. We're going to create a special method for the dog for eating. So I'm going to click on that. And Java will come up automatically and give you this @override symbol. And that's to remind you that we're overriding a method that is in the super class. In this case, it's in the animal class. So now both the dog class has got its own eat method, and also the animal class has got its eat method. So what we can then do here is we can just put something to indicate that we're calling it here. We'll put dog.eat called. And let's also put chew, and we'll say the process of a dog eating food is that it's chewing. So we're going to call our method that is unique to the dog class. And then we're going to use super.eat. And what super means is call the super equivalent of that class. So super dot and the name of the function. Java will automatically come up here and go, okay, the super class for this current class is animal. So it's going to go back to here and look at the eat method and call that. So let's run that and see what happens. So what's happened is the dog.eat method was called. So if you recall previously when we called dog.eat, it went automatically into the animal method and it called this method here in the animal class because of course we didn't have an eat method in our dog class. But now we've added an eat method to the dog class. Dog.eat method has been called first. We then use chew, which called the private method chew in the dog class. But then we use super.eat, which called the animal.eat class. So that's using inheritance. So this video is getting quite long. So let's continue this in the next video.